Hello, my name is Leander Hutton. I work here at Appalachian State University in the Research Computing and Systems area. Today I'm going to demonstrate to you a new way to use our HPC cluster called Open OnDemand. It is available without the VPN worldwide. All you need is a web browser. Just go to ondemand.appstate.edu and you'll be presented with the Mountaineer ID or Shibboleth login screen. Log in with your ASU username and password, and then you'll be dumped out here on this screen, which is the welcome screen for Open OnDemand. We have the message of the day here, and that's not really message of the day is a bit of a misnomer. It's more like message of the week, month, or whenever we need to communicate something to our user base. Patch days, new changes and whatnot should be posted here. We also mail those out to our mailing list, so one way or the other, hopefully you'll find out about it. Up across the top here, we have a few different menus and modules to use. Starting from the left, we have the Files module, one called Jobs, a Clusters, and Interactive Apps. Probably the first one you're going to want to interact with is the Files module, and you'll click on your home directory here. And this is very similar to Google Drive or OneDrive or any number of cloud-based, web-based file managers you may have encountered in your computing career. You will get a list of your files available here. This is just the same stuff that you should have through the SSH interface. If you've ever SSH'd into HPC1, which is our login node, this is the same stuff. It's the same storage mounted up. You've got a few options across the top. You can open a file in a terminal, you can refresh, add a new file, create a new directory, upload and download, copy, move, and delete. Pretty standard file manager stuff. You can also come here in the hamburger menu and you get all sorts of other options, so rename or download. If you select a text file, so I have this apptainer test shell script here, and I will click edit. It'll give me an edit option, and it'll give you a text editor, a web-based text editor. So you could come in here, edit this file, say change that to HPC D3, and you can click save, and it'll save the changes to the file on the storage. So you no longer have to use Vim, Nano, or Emacs as a text editor if you don't want to. You could just use this basic web-based one. When you're done with it, you just close out, and you're back out to the file manager window. You can also download things, so you can check this box here and then click download. And for a folder like this, it's going to zip it up into a zip file and download it for you. You can upload a file. If you click that, you'll open a web file system browser window, and it'll allow you to upload things. There is a 10 gigabyte total upload limit to Open OnDemand versus the old way of doing things, which is SCP and rsync to the login node. If you need to do more than 10 gigabytes, please use rsync or SCP or SFTP into the login node over the VPN. But 10 gigabytes should get, I'd say, 80 to 90% of the research data uploaded through this web interface. Once again, just to reiterate, the backend for all of this is the same set of disks, the same storage. So whether you upload it through Open OnDemand or directly through SFTP, SCP, it's all going to the same set of disks on the same machine. So this is just another way to do it. You don't have to do it this way. Logging into HPC1 over SSH is not going away. This is just a new, more user-friendly way to do things. After you're done in here, you've got a few other things you can do. You can look at our active jobs. So we're going to go here to active jobs. Right now, I don't have anything running. So by default, it should drop you out to your jobs. I had it set to all jobs because that's what I last looked at. I don't have anything running, but if I look at all jobs, you'll see that there's a number of people doing some research work here, and you can see the ID, who's running the job. You can't get a whole lot of details on it because it's not your job, but you can see the end date and whatnot. So if you're looking at requesting a large amount of resources or a large amount of time, this might help you plan that and when you need to submit that job. Right now we're not terribly busy, and you can tell that by going here to clusters and going to system status and give it a second. It goes out and queries all the nodes and stuff, and it gives you a list that we have 3 nodes available, we're 40% in use, and we're only using 10% of our processors. We do have 2 GPUs available only to the computer science users. There's a special node that computer science bought for the cluster, and they've got a couple of NVIDIA GPUs in them. These are not available to the general public. You don't have permission to use them. But if you do have grant money and want to buy a GPU for the cluster, again, you can do that by contacting us. And actually, there's a great way to put in a support ticket right from this web interface. If you go here to the Help menu, you need to contact support for any reason, you just click Contact Support, and it will dump you right out here into Jira, into the Research Computing Request form, and you can contact us straight from there. We also have a couple other links here. We have an online documentation which takes you to reswiki.appstate.edu and a restart web server. At any point, if Open OnDemand is acting a little funny for you or something, sometimes there's some timeouts. It has some issues where sometimes if you like close your machine and go somewhere else that it doesn't reconnect correctly or cleanly. You just go in here and restart web server. You click that, and it won't harm anything. So Open OnDemand is completely isolated from Slurm and the login node. So if you do restart the web server, it's not going to cancel any jobs or anything like that. It'll restart your web server more cleanly, and you'll be able to start working again. But that's kind of it for the basics on moving around in here. We're going to start delving into the apps and what you can actually do. First thing to look at here under clusters is the ASU HPC cluster shell access. This is a bash shell just like you could get through SSHing in. It's just done in a web browser, so it's a little bit easier to get to. You don't need to install software on your machine. You can come in here and edit your Slurm scripts or whatever. You can SQ, you can look at your Slurm queues and stuff in here, just like you would through SSH. And once again, to reiterate, the traditional SSH is not going away. This is just a new way of looking at things. And it might be more user-friendly to someone who is not used to a Linux environment. So you can come in here and you can sinfo, it'll print you all of that information available to you there, just like you would in the standard bash console. When you're done, you can close this window. Yep, I'm sure I want to leave page, and it'll dump you back out into Open OnDemand. The new and probably most exciting thing for our users is these interactive apps that Open OnDemand provides. Right now we have deployed 2. We have the ASU cluster desktop and the computer science desktop. We will be adding more in the future as we go, hopefully by fall. I don't want to paint myself into a corner there, but maybe we'll have some new ones by fall. We're kind of taking it as we get them debugged and ready to go. But we're launching with 2, and probably most of you will be looking at this ASU cluster desktop. This is basically a GUI for the cluster, and it also takes care of all the Slurm backend stuff. So you don't have to worry about editing a Slurm script or editing a shell script, submitting it with SBatch and all of that. This takes care of all of that on the back end. It hides it all from you. So it's much more user-friendly. We have some predefined sizes here for you to select from, tiny, small, medium, large, etc. We've got 2 partitions available, compute and debug. Debug are our 2 older nodes that we have laying around. They're getting up there now. They're pretty old, but they are still useful for classroom use and for testing use. So say you're writing a program, but you're not sure how it's going to react, so you want to check it out before with a smaller data set before doing your big compute run. I would highly suggest trying it out on the debug node with a smaller data set, making sure everything kind of works like you expect it to, and then submit it to the compute node. There's nothing worse than submitting a big job, having it fail halfway through because you didn't see a bug or something like that. It's great for that. The debug is also great for classroom use. So if you have a class who wants to use the HPC, and we all know how you know, how rough students can be on equipment sometimes. The debug partition is a great place for them to get their HPC sea legs, as it were, and learn the ropes and learn how to do things. So again, classroom students, I would put them on the debug cluster, or debug partition, excuse me. One final thing about selecting the debug partition here is that I would recommend sticking with medium or smaller, so tiny, small, medium on the debug partition. These are older machines with less RAM, fewer CPUs, slower CPUs. You know, these larger ones, it may not be able to accommodate them. So I would stick with these kind of smaller sizes on there. Another note about these resource limits here is that your task that you're having to do needs to fit inside of here. So if you're running uh, R Studio or Jupyter Notebook or what have you, you have to kind of figure that it has to fit inside this amount of memory and this amount of CPU. These are some predefined sizes we kind of cooked up in testing. If you do need a larger one, please put in a support ticket and we'll try to figure out um, and we'll do some testing and see if we can accommodate you there. We will do our best. But this should get, I would say again, the 80 to 90% of the HPC users just need something slightly bigger than their laptop, and a lot of these will fit the bill there. So let's go ahead and try this out and show it off a little bit. I'm going to select a small unit here, and then I'm going to go on the compute side of the cluster here, and I'm going to click launch. And I'm going to go ahead and let it go. Oh, the hours. You notice at the top of the form it said hours. You can request up to 168 hours and a minimum of 1 hour. So use that as you see fit. If you do run a job that is going to last, you know, more than a work day and you want to take your laptop home or something, you could do that, and this will keep it running in the background. You don't need to worry about leaving your web browser open or anything like that. As you can see, it took it a couple of seconds to launch and get sorted, but we are running now. We have one node, and we're running on 4 cores. We're running on hpc2.appstate.edu. And Open OnDemand interfaces with Slurm, so it's going to pick, you make it HPC3 on yours, it's going to pick the place where is least busy and where your job will fit in the best. So now that we have it created, we can click Launch ASU Cluster Desktop, and you're going to launch into a desktop window. Now, I've been on this before, in fact, today, so it opened a terminal, but when you launch yours, if you've never done it before, it's going to end up with a blank desktop like this. This is XFCE, which is a Linux desktop environment, free and open source. It's probably most similar to Windows start menu driven desktop interface. So if you are familiar with that, this should be piece of cake to you. This applications menu is pretty analogous to the start menu. You can go through here and dig through whatever applications that we have. I'm probably going to be adding VS Code to the cluster here soon, so that will show up in here and whatnot. But for right now, we've got a terminal, a file manager again. So this is just like Windows Explorer. You can look at your data here in a file manager, or Mac OS Finder. We have a web browser. So Firefox in this case, you can go to the net and you can look at stuff on GitHub. So we can say GitHub Astro Interactives, and you can clone stuff from GitHub. I think I've already done this once, so let me bring up my terminal here. I'll rm-rf that. Yep, I already had that on there. But you can git clone, and copy and paste that. Copy and paste. Trying to do things with the menus so you can see it. And I did an insert and put some characters in there. That was my fault. And it'll clone in just like you would on your desktop. Again, so you can use this like a regular desktop computer. One thing to note, all of this is running inside of Slurm, like I said before. You do not need to SBatch anything. In fact, don't do that. You just run things like you normally would on a computer, like you normally would on a Linux computer. So I can come in here and do lmod or module avail, and it's going to list all the modules. I can module load R405, and now I could use R right in my terminal here, just like I would on a normal computer, and it's going to run on the HPC node here, just like you would if you submitted it in a Slurm batch script. But you don't have to worry about all of that. Open OnDemand takes care of it in the background. Cool, right? So if you're done with your desktop, you can close out of it. I'm going to close out of all of this and log out, and it'll shut it down, and you'll see the card will stay here for a little while after you shut it down, and you'll be able to access the data. So yep, it shut down. You can see it's now it's the status of completed. You can come in here and take a look at the output data. So if you're having issues with it, you can come in here and look at the output log and see what maybe went wrong. It might help if we need more information from you on troubleshooting. So that's kind of the main meat of this whole thing. There's a lot of stuff you could do with the desktop. I will say the computer science stuff here, if you are a computer science user, you'll be going and using this. You do have GPUs to select in addition to the number of hours and the size. The partition, you only have one, is the CS GPU. That's the big difference. If you're not a computer science user, this will fail. It will not allow you to submit. So no worries there. But this is the meat of it. I will have a video after this about using Python virtual environments and Jupyter notebooks through the interactive desktop, virtual desktop. One side note, we do have written documentation here if you prefer that to a video. If you go under AppState HPC Introduction, everything I went over is here in this wiki here that we've put together. So we've got screenshots and text and all that stuff if you prefer this way of getting your information. And we've also added a couple of new pages here on doing Python environments, virtual environments in Jupyter Notebook. So this is also through the virtual desktop application in Open OnDemand. Again, there'll be a video on that, but if you prefer it in written form, it's already here. And we also have one on building Conda environments in Apptainer, which is a Podman Docker-like container system for HPC. So we've got a little bit of documentation here on doing that. And that is, once again, res-wiki.appstate.edu. Once again, my name is Leander. Thank you for watching this. I hope it was useful, and I hope you get some good use out of Open OnDemand. If you do find a bug or a problem, please feel free to report it. And hopefully you will have some good success and get some good work done on this. All right, thanks, and have a good afternoon.